Next up, we're going to use some functions or forms of the functions to help us graph. So the two forms we're going to use are standard form and vertex form. The standard form is the one you're probably most familiar with. It's f of x equals ax squared plus bx plus c. Now that c value is probably going to be the most beneficial or the quickest thing for us to graph because the c value is our y-intercept. Now there's also the vertex form, which we've used in the past before. That would be f of x equals a times x minus h squared plus k. And in this case, hk is our vertex. So the h value, if it's x minus 2, that'd be x equals 2 as our h value. So that'd be the x coordinate of our vertex. And the k value would be the y coordinate of our vertex. So at the bottom here, we've got two graphs. Let's focus on just the one on the left first. We're asked to sketch the graph using what we know and also find the zeros slash x-intercepts. Same thing. So r of x equals negative x squared plus 6x minus 8. Let's just start off with what we know. Our axis of symmetry. Well, maybe we should label A, B, and C. A, negative 1. B, 6. C equals negative 8. So our axis of symmetry is going to be x equals negative, our b value again was 6 over 2 times our a value, which was negative 1. So we have negative 6 over negative 2. Sorry, I was thinking ahead to the answer, which gives us x equals 3. So we're going to have a vertical line at x equals 3. I'm going to draw this as a highlighted line. If you don't have a highlighter on you, I would say maybe use the dash line, but this is going to be kind of our basis for the rest of our graph. To find our vertex, oops, sorry, that's a highlighter. To find our vertex, we're going to take that x value and plug it in. So the x coordinate is 3. To find the y coordinate, we're going to plug that in. We're going to do r of 3. So we're going to have negative 3 squared plus 6 times 3 minus 8. When we clean that up, we get negative 9 plus 18 minus 8, which gives us a coordinate at 1. So we have a coordinate at 3, 1. And let's plot that on the graph. Now to find some zeros, that's going to help us with the rest of the graph. To find the zeros, remember we got to set the whole thing equal to 0. So we're going to have 0 equals negative x squared plus 6x minus 8. Now, we're going to have to solve for x here. I'd say one of the first things I would do is multiply both sides or divide both sides by negative 1. So we have 0 equals x squared minus 6x plus 8. From here, we can factor. We got 0 equals x, two numbers that multiply to 8 and add to negative 6. We got negative 4 and x minus 2. Now, using the zero product property, either that first group's equal to 0 or the second group's equal to 0. So when we solve for x, we get x equals 4 and x equals 2. So if we put those on our graph, our x-intercepts of 2 and 4, we have points right there. This is really enough to get a decent idea for what this graph is going to be. Another thing that we could do is we could plug in other points, like what happens if we plug in x equals 0. If we plug in x equals 0, we do f of 0 equals negative 0 squared. Oh, my goodness. I'm thinking of doing work that we don't really need to do. We also know the y-intercept already. The y-intercept. I was literally about to calculate that, but we already know it. The y-intercept is that negative 8. We were given that. Now, because this is an axis of symmetry acts like a mirror. So this point, well, let's go to the 2 points up here. The point at 2, 0 and 4, 0 are mirror images of each other. They're both one tick mark away from that axis of symmetry. Now, this point, our y-intercept of negative 8, is 3 tick marks away from the axis of symmetry. So we're going to have another one on the other side of the mirror. That's 3 tick marks away. And this is going to give us enough points to graph. I don't know why I switched colors, but I did. But we've got an upside down, oops, sorry, I missed. We've got an upside down parabola with a vertex at 3, 1 and x-intercepts at 2 and 4. Now the last one here, we've got a different format here. This one's going to be our slope, nope, sorry, not our slope intercept, goodness gracious, our vertex form. So we've got the -1 here and the +2. Let's just start with this. Our vertex is, careful, it's not x equals -1, it's x equals 1 and a y value of 2. Our axis of symmetry, the axis of symmetry has to go through that vertex, so it's going to be the line x equals 1. Let's plot those before I go any further. 1, 2, and then the axis of symmetry that goes right through here. Now I'm going to shift things around a little bit so that I'm not covering up important information for this problem. There we go. So let's zoom in a little bit. To find some zeros, let's start by setting the whole function equal to 0. So, sorry, that's a highlighter still. So for our zeros, we'll do 0 equals 2, sorry, I forgot the rest of it, -2 x minus 1 squared plus 2. So what I would do in this one, just start solving for x. So let's add 2 to both sides. So we have 2 equals -2 times x minus 1 squared. Trying to get rid of everything that's not x. Let's divide both sides by -2. We end up with -1 equals x minus 1 squared. Now, to solve for this, I made a mistake, didn't I? Let's fix that. Does anybody see where I made a mistake? I'm asking you and you can't answer right now. I meant to subtract 2. Thankfully, that just changes one little line here. So this becomes a -2, which makes this a -2, which makes -2 divided by -2 positive 1. That's going to make a big difference. Okay, let me zoom in on this a little bit so that I don't make any more mistakes. So we have x minus 1 squared on one side. We got to get rid of that square, so we take the square root. So when we square root the x minus 1 squared, we're just left with x minus 1. And when we square root 1, we get 1. But wait, there's more. It could be positive 1 or it could be -1. Both positive 1 and -1 are square roots of 1. Now, when we've got this set up, we've got to split this into 2 cases. You've either got 1 equals x minus 1 or -1 equals x minus 1. Either way, we have to add 1 to both sides. And this one, we'd end up with x equals 2. Over here, on the second one, if we jumping ahead. Not even jumping ahead. If we add 1 to both sides, we end up with x equals 0. So those are our 2 zeros, x equals 2 and x equals 0. So let's plot those on this graph. So x equals 0 and x equals 2. This is enough to get us a good graph. It's going to be a downward facing parabola again. Sorry, be a downward facing parabola again. That goes to those points. And that's all.